Okay, the learning curve, actually the impact, as you people, some of you have said, and you know that, the learning curve says that the more you do of some activity or task, the faster you become. So you become fast with practice. This is very simple concept idea. And what it does, why do we need it? It saves our labor cost and saves our variable overhead due to less time spent. Because when you start spending less time, your labor cost will go down and your your overheads will go down. Material cost and fixed cost, they are not impacted. There is no impact on material cost and there is no impact on your fixed overheads. Now, the idea behind learning curve, what type of businesses it works, let's go back to some slides and we'll see the chapter theoretically, and then we come back to calculation, because learning curve calculations are important and sometimes they become tricky if you do not know. So I'm just sharing you with my slides.
So we are actually practicing this thing in practical scenario or in field as well. This learning curve.
It is very useful thing, and
Very
that
practical.
is why
Yes, sir.
that is why I told you that I decided to do it in the very beginning. I mean, this is some knowledge which you have in the beginning, so that when we are doing F5, this is somewhere lying in your mind, okay? And whenever we need, we will take it out from our pocket. This is something we always keep in our front pocket. Whenever we need it, we use it. We will use it in target costing. We will use it in budgeting. We will use it in forecasting. So we will be using it in many different scenarios. Learning curve, general idea.
I found it in section D, I think, yes, as well.
In the book, they do it very later, but I want to do it first. I mean, I don't want you to take on the ride without having learning curve in your pocket. So the general idea, the more you do something, the faster you become at it. Requirements, where does it apply? It applies in large manual element, because machines do not learn, human beings, they learn. So we start with that word, that this learning curve thing will apply when you have labor element more. If your production process is machine oriented, probably learning curve will not have very significant impact because there are not many people. But when you have some businesses which are called labor intensive businesses, where you have a lot of labor, at that time large learning curve will apply. And I gave you the example of this garment manufacturing factory. Learning curve 100% will apply there, because there are people who are sitting on the stitching machines or you know, in other departments. So it's a labor intensive thing. Of course, equipment is there, machinery is there, but the people, they play an important role. The nature of job should be repetitive. For example, if you talk about garment manufacturing which makes shirts, so you have to do the division of labor, so that one person is making only collars, one person is making only, you know, pockets, and one person is making only sleeves. Only then he can become faster. But if you tell him that today you will make collars, tomorrow you make pockets, and the day later you make sleeves, he will not gain that speed. In order to gain the speed, in order to become more efficient, the work has to be repetitive. He should come in, start making collars day in and day out, every day. He will become fast. And it is always in the early stage of production, which means that the learning will stop after some time. So today when he starts, so he probably is making like, you know, 20 collars per day. Next day he can make 25, then he can make 35, then he can make, I don't know, 40, and then the learning will stop, because he has already achieved the maximum efficiency which is possible. Beyond that, it is not possible. It's not possible that he would be making 1,000 collars per day. Consistency in workforce, that people, you should keep the same workforce, because if you keep on changing people or rotating people, learning will not be there. So in order to have the learning impact, the team, the people should remain same. And no breaks in production, because then of course efficiency will be lost. So it has to be a very fast production process and motivated workforce. People should be motivated to work fast. Why somebody should work fast? when you are not paying them more. So you have to motivate them. You have to provide them with some incentive so that they try to learn, and so that they put in all their efforts to become more efficient, and to become faster. So these are some conditions, and sometimes they may give you this thing in a conceptual question.
No break in production.
No break in production, because when you have breaks in production, then your efficiency thing, because we are talking about efficiency, how do you expect increasing efficiency when production is interrupted?
Okay. Okay.
So learning curve theory. So please pay attention to the definition. It says that as cumulative output doubles, as cumulative output doubles, cumulative average time, cumulative means average, okay? The cumulative average time per unit falls to a given percentage, 80%, 70%, 90% of the previous average time per unit, of the previous average time per unit. Now let me show you the numbers and then we'll come back again. So let's suppose that as the output doubles, so 1, 2, 4, 8, I'm doubling the output. So you have total time. So total time taken on 1 unit. So cumulative average time per hours. So if it is 100, if 1 unit takes 100, logically 2 units should take 200, but 2 units are taking 150 hours only because of some learning curve impact. And if you see that here the average time is 100 divided by 1 is 100, and here the average time is 75%, which is 75, then it becomes 75% of this. The cumulative average time will fall. 75% of 75 is 56.25, and 56.25 you multiply with 4, it becomes 225. And similarly, it moves on. So if you can see that there is a 75% learning, you can start from here, you can start from here, makes no difference. So you can say that if 1 unit is 100, 2 units should be 100 multiplied by 2, which is 200, but it is not 200. 200 multiplied by 75%, it is 150. If it is 150, so per unit is 75. For 2 units, it is 150. For 4 units, it should be double. Okay. 2 units are 150. 4 units should be 300. But it is not 300. It is 300 multiplied by 75%, 225. And similarly for others. Now let's move to Excel file where we can see it in a better way. Let me share with you the Excel file. I think now you have got the Excel file. So if I say that, I'll repeat this again, okay? So what I'm going to do, I say you've got 1 unit and it takes, let's suppose 100 hours. So 2 units actually should take 200. But let's suppose that we are saying that our learning curve, okay, let me change the data. 1 unit takes 50. Then 2 units should take 100 generally. But if I tell you that your learning curve or your learning rate, now there are words which I'm going to introduce here, is 80%, okay? There are 2 things. One is called learning rate and one is called learning index. And I'm going to show you what does that mean. These are 2 different things. So if your learning rate is 80%, so you just have to, 2 multiplied by 50, which is 100 times 0.8. So 2 units are taking 80 hours in total. So this is my total time. And here I will calculate my average time. And my average time will be 50 divided by 1. And here the average time is 40. So you can see that is 80% effect. So if you go now to 4 units, so 4 units should be taking actually 4 units should be taking, 40 times 4, which is 160. But it is not taking 160. You have to multiply it with 0.8. So it is taking 4 units are taking 128 hours in total. Average time has reduced. So if you see that for making 1 unit, the average time is 50 hours. For making 2 units, the average time has dropped down to 40 hours. It is 80%. Then for making 4 units, the average time has further decreased to 80%. It is 32. It is actually 80%. 80% of 40, I mean, you can calculate 80% of 40 means 32. And as your production doubles to 8 units, then it will happen this multiplied by 2 into 0.8, 204.8. And you see that the average time. Now, what is 25.6? Please pay attention. 25.6 is the average time for making 1 unit if the production goes until 8. So when you produce 8 units, the average time per unit is 25.6 and the total time to produce 8 units is 204. The total time to produce 8 units is 204. And within 204 hours, the first unit took more time, like 50, the second and third units are taking some other time, and fourth and fifth are taking some other time. So this is the tabular format of finding out the time, average time. We are actually interested in calculating the average time per unit. Now, there are two problems with this table. Number one problem is, what about unit number 3, or what about unit number 5, 6, or 7? Was there any learning there or not? You cannot say. So actually learning curve diagram, it looks like this. So here it is your time taken, and here it is your quantity. So first unit when you made, your time taken was 50 hours. But as you are increasing, your time is decreasing, okay? The time per unit is going down. This is called learning curve. But if I see this graph, according to this graph, it is like this. It is going in steps, okay? Which is not like proper thing. It has to be in a curve form, because learning does not apply only to the 8th unit. The learning applied also to the 5th unit, to the 6th unit, to the 7th unit, and then of course the 8th unit. So learning is a continuous process. Learning does not happen that when you will only make it, only at that time learning will happen. So with this table, this is one drawback. The second thing, which is with this table, and we say in many cases, we say that the learning will stop at some point in time. Let's suppose that our learning stops at 64 units. So it means now I have to calculate 16, I have to calculate 32, and then I have to calculate 64. It takes more time. What if we have some formula? So we have got a learning curve formula as well, and we will do it with the help of the formula actually in exam mostly. And the learning curve formula is y is equal to ax and power b. Y is equal to ax power b. This is your formula for learning curve. Now, what is y? Y is your average time, and a is your time taken on first unit, and x is your number of units or batches, whatever, and b here is called your learning index. Now I'm using the word learning index. See, I told you that learning rate and learning index are two different things. Learning rate could be 80%, what we were doing here in this particular question. We were saying learning rate is 80%. But what is the learning index? B is actually learning index. Learning index is log of R, and you have to use your scientific calculators. Log of R divided by log of 2. And you can use it in your scientific calculators very easily. I will show you how to use it. So if I see that these are the, so I need to find out actually y. This is my y. This is y. Can I find out this number 25.6 with the help of this formula? If I start putting the values in this formula, can I get the numbers? So how would we would do it? We'll say y is equal to A is the time taken on first unit. Time taken on first unit is 50. Multiplied by, you've got X. X is the number of batches. In our case, it was 8. I will explain you learning rate and learning index once more, okay? So I know that you still have some question in mind about learning index rate. I will come back to it once I show you the formula. So your X is, which is number of batches or which is number of units, and that is 8. And then you have to write down B, and B, power B actually, power B. And B is log of R divided by log of 2. And we need to calculate that. In our case, we would say that log of R, which means log of 0.8. Log of 0.8, because our learning rate is 80%. So I would say log of 0.8 divided by log of 2. Now you have got scientific calculators. You need to take that in exams. Now, even if you do not have now with you, you can open up your calculators and you just tilt your calculator and your simple calculator will be converted into scientific. In most iPhones and Samsung, it normally happens. You open up your calculator, you tilt your phone, to landscape view, and it will become scientific. Please take out your calculators. We will do it now together. So you have to use this log thing, log of R divided by log of 2. So if you have your calculator, you've got the log function here. The thing is that first you need to put the value. So we need log of 0.8 divided by log of 2. So I would say 0.8 log. Then I would say divide by 2 log. So if you see on the top, it looks like this. Log of 0.8 divided by log of 2. And then you just press the equal to sign and it gives you the value. The value comes out to be minus 0.3219. So I'm taking the value. Please remember the log of 80% learning rate, the learning index. Now this 0.3219 is your learning index. So if you have learning rate 80%, the learning rate 80%, the learning index is minus 0.3219. If in exam question, they say you that the learning rate is 75%, so you would simply say 0.75 log divided by 2 log, and you put equals to, and this would be your 75% learning rate. This is your learning index, 0.415. Now let me find out again what was I just forgot, 0.8 log divided by 2 log. So it is minus 0.3219. So we go back to our Excel sheet. We share the screen with you on Excel. So we come here. I'm sure you people can see now the screen, Excel. Yeah. So yes. We come back here, and instead of this thing, I'm now putting minus sign 0.3219, okay? So this is how my formula looks like. And now I will copy paste it here, and I'll just remove this y so that it gives us the value. And it gives us 25.6, and we will try to round it off, and 25.6. And how much did you calculate there? You got 25.6 there, you got 25.6 here. So if you have this formula, and if I tell you that, let's suppose that we say that learning continues until 16th batch or until 16th group. So you don't need to do anything else. Just take these numbers here. This is the formula. Instead of putting 8, just make it 16. Because this is your X. X is the number of units or number of batches. So here we were using it for the 8th number. So if I have to find out for the 16th, I'll just replace the word this one. I'll just replace 8 with 16. And I'll put it here 0. And it gives me 20.4816. And you can apply it here also. You can say this, for example, this multiplied by 2 into 0.8. And this I will copy paste. It will give 20.48. And this also gives 20.48. So why I'm showing you this formula? Because after showing you the formula, I'm going to say goodbye to this table. I'm not going to use this table anymore. Okay,
So this multiplied by 2, I didn't get.
Because if 8 units are taking 204, 16 units will take this multiplied by 2, multiplied by 0.8. If production is doubled, time should also be doubled or not. For example, it should be 204 times 2. It should be like when you are doubling the production, this is also made, this also should double. But if you double it, then you have to multiply it with the learning rate, which is 80%.
Yeah, got it, yes.
So I just forget about this table now, and I come back here. Now, my question to you people, that when we made 16 units, the average time taken on the average time taken is this one, right? When you make 16 units, the average time taken is 25.6 hours. No, this is for 8, I'm sorry. For 16, it is this. Am I right or not?
Yeah.
What is this 20.5? Is it the total time or average time? Average time. So I ask you that total time taken on making 16 units. So how much is the total time for 16 units? So you should put 16 here and you should multiply 20 with 16. So the total time taken on 16 units is 327. This is what you have calculated above, 327. And I just put it here. So it's nothing serious. I'm just playing with the same numbers. 1 unit, when I make 16 units, 1 unit is taking 20.5 hours, and 16 units are taking 327 minutes or 327 hours in total. Okay, I understand. Now, my question is that, what is the time taken on 16th unit? This is the question. This 20.5 hours, it is the average time of all the 16 units. Now I'm asking 16th units, 16th unit, the last unit which you made, how much time you have taken on that? Can you tell me? Can somebody tell me? So this is a very typical question. This is a very typical scenario which comes in exam. The time taken on the 16th unit. Now, I know the total time taken on 15 units. If I can calculate total time taken on 15 units, if I could calculate total time taken on 15 units, and then I subtract from that total time taken on 16 units, the difference is the time on the 16th unit, right? Do you understand my point?
Yeah.
The best way of doing it is that find out the total time taken on 15 units. So how do I do that? I go back to the formula, and instead of this 16, I put 15. What do I get? 20.91. So total time taken on 15 units will be 20.911 multiplied by 15. So what do I get here? So the total time taken on 15 units now is with you 314 hours. And here it is 335 hours. So you can say that time taken on 16th unit is the difference between these two, 335 minus 314, 21 hours you spent actually. The time which is taken on the 16th unit is 21 hours. Actually,
21 hours?
That does not
make sense.
That does not make sense because it should not be more than the average. This is the last unit. Okay, it is, let's increase like this. There's a very, no, it is still more on the 16th unit. Let me calculate 20.92. How did we get this one? We said this is the time taken for 16 units. Then if
Yes.
we use it for 15 units, we put 50 times 15 in this factor, it becomes 20.91. And how did we get this one? Okay. Oh, sorry, because we changed the numbers here. So this number was also changed. 335 was also changed because it is coming from, it is linked with the formula. When we put here 15, see here, first it was 16, okay? So it should be 328. Now I should write down 328 with my hand. And then I will make it 15 because it was linked in the formula. Now it is here 15, and now it is 14.335. This is the time taken on the 16th unit. Why it was giving error? Because when I changed this number with 16, I made, instead of 16, I made 15. This value also automatically changed, which was 16 unit time, because formulas were linked. This is also D81. Let me go back again. It was on 16 unit. Please follow me. On 16 unit, your average time is 20.482. I make it 20.482. And this, I will say this multiplied by this. So 328 hours is on total time on 16 units. And I just removed the numbers. I just put it like this, okay? And then I make it 15 because I was using the same formula for both of them. And now it is 20.91. So 20.91 into 15 is 314. It is giving you some time about 14.05 or 14 hours. So 16th unit is only taking 14 hours.
Easy.
Do you understand?
Yeah.
Before it was a little bit mistake because I used the same formula for both calculations.
And we understood, sir. Understood. Understood. Yes. Yes.
Now, what you need to do now, coming back here, what type of questions they give you? You know, they say you that you have an order for producing 16 units. So let's suppose that a customer places an order for 16 units. And you have to make a budget, or you have to make, a cost for making 16 units. There will be a significant difference, because if you do not know the learning curve thing, let's suppose that your material cost, your labor cost, and your variable overheads are, for example, you say that in 1 unit material is $30, labor is your, per hour is $10 per hour, variable overhead is $5 per hour. So let me write down it completely so that you understand what type of question, how it is applied. So you say that material per unit is 30, labor per hour is $10, variable overhead per hour is $5. And if I ask you to start making it for 16 units, you would say $30 for 1 unit. And for 16 units, I multiplied with 16, and you would say that my material cost goes like this. But when you talk about labor, you would say that, oh, my labor is $50 per hour, 50 hours per unit. So you will start saying that, like, do you understand my point? What will happen? You will say that 16 units, each unit is taking 50 hours, and the cost is $10 per hour. And the cost is $10 per hour. Cost is $10 per hour. You will multiply it with 10, and you will take 50 hours. And where will your cost go to labor? Your labor cost will be like something like 8,000. Okay, because we took a very huge number of hours. 50 hours per unit is too much. Anyways, it goes like this. But once you know the learning rate thing, you know that your average hours are not 50. Your average hours for making 16 units is just about 20.48. And when you put here 20.48, your entire budget is changed. Instead of 8,000, it is 3,276. And the same will happen with the variable overhead, because If you do not know the learning curve thing, you will think that I will be spending 50 hours per unit. But whereas in reality, when the learning curve will apply, you will be making only 20 hours on average per unit. So you should be multiplying it with 20.48, not 50, and instead of 50 hours. So we use the learning curve concept in target costing. We use the learning curve concept in budgeting. For example, when you talk about target costing, your budgeted cost probably is $30 and your target cost is like $25. So 30 is budgeted, which means what you are achieving, what you are doing now. Target is 25 and you say that there is a cost gap. You say that there is a cost gap. So you call in your production supervisor, your production manager, and you say, listen, we have to make it in 25. This is our target cost. You are making it in 30. It will not work because we are losing $5 per unit. And here your production manager will say that, yes, we are going to lose 5 now, but very soon when the learning curve will apply, this budgeted cost will go down, because right now I am making this based on the initial units, but as the production will increase, as we will move forward, the learning curve effect will start coming in. This number of hours will decrease, and therefore the labor cost will go down and variable cost will go down, and maybe we will be making it in $22. So please do not say no to the client. Let's say yes to the client. We may not be making it in the very beginning, but very soon the learning curve effect will come in and our costs will go down. So it's practically in real life a very applicable concept. And I cannot imagine an F5 paper without testing your skills or knowledge or understanding of learning curve. So there are two things to it. One is the concept. You understand what it is. Which costs does it impact? It impacts your labor and variable overhead. It does not impact material. It does not impact fixed overhead. So you apply it in the early stage of production in the businesses which have huge manual labor element. The nature of job is repetitive. Staff is motivated to work fast. It will decrease your labor and variable overheads, but the learning will stop after some time because it cannot continue to eternity. At some point in time you will already have achieved your all of the efficiencies. And you know that how to calculate the cost of 15th unit. This is something they usually ask. Cost of making 29th unit. They may ask you what is the cost of making total 60 units. So you calculate the time taken on the 16 units total. Or they may ask you the 15th unit cost. What is the cost of making the 15th unit or the 16th unit? I know that 16th unit is $14. Average is 20. Why average is more? Because within this 20, 50 hours, 40 hours, 32 hours, all hours are included. Therefore, average is more. The last unit should be at the minimum time. The minimum time is spent on the last unit because that's the height of your learning. And then you know the difference between learning rate and learning index. You know how to calculate it on calculator. Log of R divided by log of 2. And you know the formula. It's not very difficult. Once you understand, questions are very similar.